Hi, this is Elisa. I would like to try to make the free fall chart, that particular assignment, a little bit more understandable for you. Whenever we have things that are just sort of static on a piece of paper, it can be a challenge to provide enough information and yet not confuse people. So let me see if I can help out here just a little bit. What you're looking at right now is the first chart on the free fall. So let me orient this to you because I can see where a piece of it could be read two different ways. We have the different columns. We have time. We have acceleration, which is a constant. It's actually 9.8 meters per second square, but we're going to use 10. This is the instantaneous velocity. At each second, what is that particular velocity? This is the average velocity. This is how far has it fallen just within the last second. And then this is what is the total distance it's fallen from when it was dropped. So that's what we're trying to look at. Up here, you'll see some things that are meant to guide you. So constant acceleration, the acceleration is always going to be the same. That doesn't mean the speed is the same, but the gravity pull is going to be the same no matter where the ball is within its fall. Instantaneous velocity, here's our clue. Velocity starts at 0 and it gains by acceleration every second. So it's instantaneous speed or velocity. It's 0 when it's first dropped. It accelerates, and so therefore it's going 10 meters per second. Every second it speeds up by 10 meters per second. So you can see the pattern here. 10, 20, 30, I'll let you guess what goes in this block. Average velocity says we're going to take the velocity of what it was the second before and the previous second. What it was for this second and the previous second. So let's look at our pattern. There's no average velocity when we first drop it. So let's take a look. How do we come up with these numbers? Average velocity, well, it started at 0 and it was going 10 meters per second at the end of 1 second. So the average speed at that time is this number and this number averaged, which gives us 5. Next pattern, we want to know what was the speed between 1 and 2 seconds. We know it started out at 10 meters per second and it ended up at 20. The average of 10 and 20 is 15. So on and so on and so on. So this note is for how you calculate this square right here. It says take this number, whatever you got there, and average it with this number, and you end up with what goes here. And that may have been confusing to people, and for that I apologize. Distance fallen within the last second. We take the average velocity and we multiply times 1. So you see the pattern here. Here's our average velocity, and this is the distance fallen just within that last second. So 5, 15, 25, I think you see the pattern here. Then we want to know, well, how far did it fall from when it was first dropped? So we're going to take these and we're going to add up the distances fallen each second. So it started at 0, it fell 5 meters, and we know that it fell a total of 5 meters in that 1 second. Well, here it had already gone 5 meters, it went an additional 15 meters, so the total meters fallen is 20. It had already fallen 15, it dropped another 25, so now the total is 45. Clue here, it should add up to 500. So it says add up the distances fallen each second. Distance followed each second, added up. One of the things I think that may have been confusing for you, and I do want to apologize, we're going to skip the second scenario. Things are calculated the same way. You have this number down here to help you figure out, did I get to the, did I do it correctly? This graph, I have updated this graph because I think the last one was a little bit confusing for you. It had just numbers over here that may have been confusing. So what we ask you to do here is to take the numbers, some numbers off of the graph, off of the calculations and charts we were just looking at. This is instantaneous velocity. So you want to go to the column instantaneous velocity. Sorry, not trying to make you dizzy. Instantaneous velocity, and you're going to graph time versus instantaneous velocity. It's already set up for you. So here's the graph. Here's time and instantaneous velocity. And we want to see what the difference is, and the first four are already placed for you. I think what was confusing about last time was in trying to make the graph fit, I started at 10 seconds, and I think that was probably not something I should have done. I think it was a little confusing for you. And then here's a couple questions. There's a second graph. Complete the graph below by adding values from your calculation. We're still comparing scenario 1 and scenario 2. So notice that scenario 1 is this chart. Scenario 2 is the second chart. So we're comparing. We're comparing what happens when you just drop a ball. That's these calculations. And then our second line is scenario 2. So I hope that helps. I apologize if I confused you in the graphing. I completely understand it, and I'll try to get this out to you as soon as possible. Thank you.